In this section, we are going to go more deeper into different kind of roles that exist in data science. There are three roles that people get confused, which is data science, artificial intelligence, and machine learning. How are these three different? Now, given many people use them for different reasons, and many people would talk about the differences in different aspects. So I'm going to give you a little idea about how to read different opinions on that regard, and then the difference between data scientist, data analyst, and business intelligence. So one fact that you need to realize is that data scientist term is relatively new. There is no specific meaning. Some people would say that it is an elevated synonym of data analyst, but it won't be correct to say that, because data analyst is only handling with data. They don't do machine learning, math, a lot of statistics. So it's wrong to say that it's an elevated synonym. It's a complete new set. So data analysis is a part of data science, but data analysts are more focused on different tools to do data analytics. Uh, Now, data scientists should have an expertise on a lot of stuff and connect and decide the data policy of extracting the data and cleaning the data and then using it into the algorithms. Uh, the data analyst guys would help us to do ETL, which is extract, transform, and load to get data from different sources. That's their job. But it's the job of the data science to get the data that he or she wants from different data sources and sit with the data analyst and get the right data. So the data scientists are expected to have an expertise in one or more programming languages, but they should have exposure to R and SAS and Python and MATLAB. Hive is how to store structured data on Hadoop ecosystem. Pig is how to transform unstructured data on Hadoop file system, and Spark is an in-memory database where you can retrieve petabytes of data very fast because the database is stored in memory and the calculations are done in memory. So these are the different paradigms, and exposure to this is required. Now, given a company has a business intelligence department, which have data analysts. A company has generally big data teams; those are expert on using big data. And in big data also you have two fields, which is big data admin and big data developers. The developers are going to develop the MapReduce jobs that are going to help us to get the data. But when we talk about data scientists, it's like you are responsible to run machine learning algorithm and math on all the data. So first you have to make sure that you get all the data. If there is some data that you are not able to get, then you should be able to write if it's on a big data infrastructure, then you should be able to write Pig, Hive, and Spark, or at least change the code to get the kind of data that you want. But the literature and a broad consensus is that the most important skill that a data scientist possesses is to explain the importance of data, which data do you want, and communicate and tell the story about the data from start to end. So all the data that is used for prediction, and what is the prediction, and what's going to be the prescriptive idea about what's going to happen in that prediction. So a data science person should have an expertise in Python and SQL and the big data tools. Now, R is a stat only toolkit, not used that often, it's fading away. SAS is a proprietary tool by a company and it's paid, so nobody's using that. It was used by big banks and insurance companies, but it's no longer used. And MATLAB was also used by big banks to do a lot of data analytics, but it's fading away. So the future is Python. The future is Python and big data. And R is gone. SAS is gone. MATLAB is gone. So now it's Python, SQL, for structured data, but most of the data that we are going to get, 90% of it would be unstructured. So SQL would be fading away as well. It's going to go away. It's going to be less important. So it would be Python and mostly Pig and Spark, which is going to be the future as per the current trends. Now let's look at the difference between data analytics and data science person. Now, data analytics guy is more about description of the data that already exists. He does not go and talk about which mathematical model you use, what do you want to predict, how are your customers, or how to get more customers or more revenue going. His idea is more about descriptive. The predictive part that a data analyst does is more about correlation and less about causation. So he'll say that sales increased when we have this or that. So there are two aspects: correlation and causation. Causation is what caused what, and correlation is if this thing goes up, the other thing goes up. So you can say that, for example, when you are not well, your performance goes down. These are the correlation, but why is your performance going down? That is because when you're not well. It's not vice versa. It's not that when your performance goes down, then you become not well. So you have to find out the causation. Data science people are more interested in causation. What is causing something? And data analytics people are more interested in just the correlation, because that's their part. Their part is important as well, because they are going to collect all the data and give you all the information about data. So no offenses, their role is getting more important, and they have to do the ETL, extract, transform, and loading of data. They have to do the data warehousing, which is create warehouse to store data coming from different sources like Excel file, SQL databases, MS Access databases. So their job is complicated. ETL is a complicated job in itself. Business intelligence is a complicated job in itself, with around a lot of tools like Microsoft ETL tools and so on. So they are the data analyst people are doing more of that. The data analyst people are not prescribing anything, so they don't tell change this business strategy. The business intelligence people would do a little bit, and they are never using the machine learning algorithm. And we are going to see what are machine learning algorithms and the common one. So the lowest part is not knowing what we don't know, knowing what we don't know, and knowing what we know. So this is how somebody would prescribe the difference between data science and analytics. Let's go more deeper and look at more nuances in this regard. So a data analyst or a web analyst uses business intelligence packages. They use intermediate statistics. They use SQL and regular expression. Regular expression is a text library to extract text. And they try to tell the story about the company's data, what happened with the company's data, where are the customers located, what happens with the sales, did it go up, did it go down, are there special trend of how the sales were going up for gender, for location, and all those kind of stuff. So they derive an insight, a curious insight from the data. They also have a story to tell. But most of the time, the data analyst people don't play with unstructured data. If they get unstructured data, they would just keep it like that. They are less interested in playing and transforming unstructured data into structured data, because that's going to take a lot of energy, so they leave it like that. As a data science guy, you have to decide what data you want, because you have to decide your features of your model, on how you're going to build up your machine learning model. They are not going to convert all of the unstructured data into structured data. So if some data is lying there, the data analyst or the data engineering team is just let it be there. They're not, because converting unstructured data into structured data is a pain in itself. You don't want to do that with all of your data. So as a data scientist, you have to go and do the data acquisition. You have to do the data movement. You have to do the data manipulation, because you know which features do you want to use. So if you say that an Amazon, if you want to predict as a data scientist what you want to show to the user, so you have to decide what all data you need for that. A lot of that would be unstructured data, like mouse movement, which page you are coming from, what did you type somewhere. Structured data would be what did you buy before. Unstructured data would be how long did you stay on the page and where were you moving, or what did you type, or the review that you gave earlier, or the reviews given to a particular product where you have to use natural language processing and all those kind of stuff. You need to also know programming and statistics, because statistics is going to be heavy in the machine learning part. So those are the parts that would differentiate a data analyst and a data scientist. Now I'm going to the right of the screen. We have data engineering and business analytics. So data engineering teams ensure that the coding and the development of the data is right. You store the data in Hadoop file system. Structured and unstructured data gets stored properly. The data that is more often required by the data science team is in Spark or in memory, and the data quality is good. The migration happens smoothly. Those are the tasks of the data engineering team. The business analyst team on the right side is like customer related data, cross department analysis. If you go deeper, it's like cubes, which is data based on geographical location, on gender, types of customer, dates, month, years, and all those kind of stuff. And the data science is more about statistic and an algorithm to boost the bottom line. How can I get more sales for the company? Given all the data that I have, how can I predict which area should I focus into? So a traditional business intelligence is what happened and why it happened. A data science guy is what will happen and what should I do, which factor is more important, what happened if I tweak that factor, if I change some part of my features, if I go on and tweak some factor, what should I do? So that's what a data science and the business intelligence guy would do. Now, as I told you, the data engineering teams mostly work with unstructured data. So 90% of the data that a company has is unstructured. You don't have the resources to convert that into structured unless it is required. The data engineering team does not know what is required because they are not taking care of your machine learning models. Uh, on the other side, the business intelligence guys, their team would work more with the structured data. They would take the structured data and create reports, which are reporting tools to tell the management what just happened with the company. That's a messy job in itself to tell the management what happened with the company, and creating into semi-structured data, or what we call partially denormalized data, to create those warehouses and all those things. So these guys are doing their job of using the data. Now, as the unstructured data increases, you have to sit with the big data guys as a data scientist to write MapReduce queries to get the data you want. You have to deal with SQL and NoSQL databases to fetch the data that you want. The NoSQL databases are already decided by the big data teams and the data is already there. But when you get that, you have to clean and wrangle the data and get the data that you want. So if I were to say, a lot of your job is taking care of the messy data, unstructured data, and cleaning and wrangling it in a way such that it could be used for your machine learning algorithm. So big data is drawn from a number of sources, structured and unstructured. Structured data, I would say, would be used by data analysts and the business intelligence people to create the specific report which the management asks them. A management would not ask them about what to do to increase my sales. A management would ask the business intelligence team to give me all the insight of how my sales happened. Unstructured data is growing very fast, like customer reviews, emails, videos, posts. We'll use natural language processing and find out the sentiment, whether somebody posted good or bad with us, which products people posted bad for us, and all those kind of things. Data scientists are more required to handle unstructured data because we just saw in the last slide that 90% of the data is unstructured, and IT persons would be responsible for managing and maintaining structured data. I would stretch that and say that they would also manage unstructured data. They just don't know which unstructured data has to be used to build up all the models because they are not worried about the machine learning models. Now let's look at the models, because I have been talking about pulling data and using data and extracting data and wrangling data for our machine learning models. So there are two types of machine learning model that we are going to use. First is supervised learning and the other is unsupervised learning. In supervised learning, we already know the why. So if I say that people who did not pay the money have certain characteristics, so I already have the data that, okay, people who defaulted had this amount of job, they have this credit rating and so on. So then you can use supervised learning. Sometimes you don't even know. Like, you want to find out who bought your stuff, and you want the computer or the machine learning to come up with the categories by itself, the age, the gender, the location. So in clustering, you want computer to create or the machine learning algorithm to create their own cluster. You don't know the number of cluster, you don't know the attributes of the cluster. So who bought my laptop or who bought my data science book? You don't know the age, you don't know which features you want to take. So it's going to completely depend on the algorithm to give you that. But in supervised learning, you know the why, you know the outcome. And in supervised learning, you have classification and regression. In classification, you just classify things. Yes, no, 0, 1. And in regression, you find out an actual number. How many pages did he read? What is the price? that I could sell it into. So you have classification, which is generally a flag, true, false, default, not default, or regression. When we go deeper into it, we read about it. But if somebody wants to know which machine learning algorithm you should know about, so here is the list: the decision tree, random forest, logistic regression, support vector machine, naive Bayes, k nearest neighbor, k means, ADA, Bose neural network, and Markov. These are the models, and they could be classified into these categories. Now, scikit-learn is the main library to do supervised and unsupervised learning. Just remember that neural network is not a part of scikit-learn. Other than that, classification, regression, clustering, and dimension reduction. I just told you in my slides how important it is for the data science guys to get the data, because they only know what they're going to do with the data. So dimension reduction is a part where you get a lot of data and you don't want to use all of it. If you want to predict something, you can predict it using 10 parameters or 20 or 50 parameters. But you want to minimize that so that you don't have to pull all the kind of data. So as a data science guy, you are going to run your model and then decide what features do you want for your data. Now, oftentimes, based on the requirement or based on a role, you hear this term artificial intelligence versus machine learning. So I would say that based on the consensus that is in the literature, artificial intelligence is a broader term and machine learning is specific to models of machine learning, specifically neural networks. So when somebody talks about machine learning engineer, these guys must be PhD who know a lot of math, because they're going to delve more into neural network. They're not going to deal so much with the data science guys or wrangling the data. They are going to deal with the math of neural network to make sure that the model works right. Now they are predicting that uh, 40 million job in US are going to be removed, or we would see a depressed wage. Why? Because a lot of these jobs would be taken up by the machines, would be taken up by automated cars, would be taken up by automated cashiers, would be taken by automated HR guys, automated traders, automated bidders, automated customer support, automated human resource teams, which is going to read resumes online and send people automated email, and based on the reply, it's going to talk with the people. So 40 million jobs are estimated to go out by 2030, and all these jobs would be going to, you guessed it right, the machine learning guys, the artificial intelligence guys, the data science guys, the big data teams, because data is going to become so important. So most of the companies, and this is an article by Forbes, that 78% of the companies said that analytics is most important to them right now, broadly speaking. And they're saying that the demand is going to increase by 28% by 2020. This is a research report by 2018. Uh, the data science analytics job, this includes everything. This includes business intelligence, data analyst, machine learning, data science, SQL developer, Cube developers, business intelligence developer, Hadoop developers, Hadoop admin, SQL admin, all kind of data science and analytics related job were 2 million. And the rate at which they are growing is 15%, and there would be 364 additional jobs in 2020. Demand for both data scientists and data engineering is growing. Data engineering is more programming and Hadoop and big data thing, and that is growing sometimes even faster than the data science jobs. Uh, Data science jobs remain open 5 days longer than average. The average salaries is 80,000. The premium over BA plus job is 8,000, and 81% of the required worker with more or 3 to 5 years of work experience. So work experience becomes very critical. Now, if I were to talk about industries and several industries, and I want to show you something interesting here. The professional services says that data science and developers are more key to us. And the finance industry says that functional analysis and analytics managers are more important to us. Now, we have not taken a lot of terms here like machine learning, but this is a survey that was done by Forbes. And they are saying that data decision driven is taking more in professional and financial services. It's still to hit its mark on healthcare and retail. Healthcare has been a dragging. We are not using a lot of databases and data analytics and big data in healthcare. It's dragging, and so is retail. But in professional services, it's going up and up, like marketing and human resource and all kind of consultancy and finance industry, finance and insurance is going up and up. So the next big revolution is going to happen in healthcare and retail services. Okay, my next part would be the data science and professions.